Welcome to Colaberry AWS DeepRacer workshop. In this video, we are going to learn about machine learning and a few cases of application of machine learning for real-world problems. Machine learning is a subset of artificial intelligence. Through machine learning algorithms, computing systems can automatically learn by experiencing the scenario over and over again. Although there are several classifications under machine learning, the main ones are reinforcement learning, supervised learning, and unsupervised learning. Machine learning is increasingly being applied to a variety of problems, from fraud detection to market pricing. Our first case relates to inventory optimization, which is ensuring that the right amount of inventory is manufactured and priced. Industrial firms collect vast amounts of raw data, like promotional campaign funds and types, prices of raw materials with lead times, and so on. Models can be created to understand correlation of different variables, as well as generate useful and actionable insights. Danone, the dairy product manufacturer, has used machine learning to model demand and forecast spends. This was done by taking data points for various variables to get these insights. As the image shows, Danone found across-the-board improvements doing this. Machine learning is also useful for computer vision. Computer vision can be used for many applications, including gait analysis and rehabilitation. Visual data from cameras is used along with footwear to analyze the gait or walking motion of individuals. A control system provides signals to an exoskeleton that will be used for rehabilitation of an individual. Reinforcement learning can be used to train a robot system to solve a Rubik's Cube. Let us watch this video now.
We're trying to build robots that learn, a little bit like humans do, by trial and error. What we've done is train an algorithm to solve the Rubik's Cube one-handed with a robotic hand, which is actually pretty hard even for a human to do. We don't tell it how the hand needs to move the cube in order to get there. The particular friction that's on the fingers, how easy it is to turn the faces on the cube, what the gravity, what the weight of the cube is, all of these things, it needs to learn by itself. The interesting thing is that kind of standard techniques in robotics haven't been able to scale to that complexity that we see in a robotic hand. Humans have evolved to be able to manipulate and operate our hands. So there's a huge amount of learning that's happened through evolution to get us to this point as a species. And the robot has to learn all of this from scratch. Instead of trying to write very dedicated algorithms to operate such a hand, we took a different approach where we create thousands of different simulated environments and learn to do the task in all of those, and hopefully a robotic hand will be able to do it in the real world as well. This means like thousands of years of experience that this neural network has had in simulation. Every time the algorithm has gotten good at the task, we make the task harder. That's really crucial because it needs exposure to really complicated environments in order to eventually be robust to the real world. You put a rubber glove on the hand and can still carry out the task. This ability to generalize to new environments feels like a very core piece of intelligence. It really changes the way we think about training general-purpose robots. Moving from thinking too much about the actual algorithms and start thinking about how do we create complex enough worlds where they can learn. At some point, then it would be more down to the imagination, what robots could actually accomplish. The hope is to build robots that can do many different tasks, to increase the standard of living and give everybody a better life.
The The following modules will further elaborate on reinforcement learning and usage in AWS DeepRacer.